don't know who these guys are, they had a Kickstarter campaign recently for their casino RPG game, and they are kind of a local success story because they have made something with bleeding edge technology and are getting it out there to the world, and it's just really, really awesome. So I'm really happy to have these guys come talk. So without any further ado, here's Goldfire Studios.
I'm James, and this is Luke. And yeah, so we're Goldfire Studios. We actually work here in downtown. We've got an office a couple blocks over, and we make web-based games with HTML5, so JavaScript, Node.js, things like that. So we're going to give you sort of a general overview of game development with JavaScript, and feel free if you've got any more deeper questions to cut us off and ask those questions. We'll be happy to talk in more detail about whatever you want to know about. So, okay, well that was sort of the overview of Goldfire Studios, but basically Goldfire started in 2008 when I was going to OU, and then we participated in the Venture Sport program here in this building. Like I said, now we're working out of downtown. There's 3 of us working on this full-time, and we're hoping to expand throughout the rest of the year. So we'll be launching our new game in about a month. So that new game is Casino RPG. We did just do a Kickstarter on it. It finished up successfully, barely successfully, about 2 weeks ago. And so this is what it looks like right now. And this is all running in the browser. This is on Canvas. It's real-time multiplayer through WebSockets. And basically the general idea is you start in the game as a janitor, and you work your way up through role-playing type features like missions, doing jobs, things of that nature. And eventually, you can own your own casino. So you've got the the tycoon aspect there, and you can of course play gambling games also like slots and poker. And so that's all again right in the browser, which we think is pretty cool. So we're targeting desktops and tablets with this. So I'm just going to show sort of our trailer for work here, give you a better idea what it looks like. And keep in mind this footage is about 2.5 months old. So yeah, let's let the stack a little bit. And if we got time at the end, we'll try and pull up a live demo of what the game looks like.
Yeah, feel free to ask as many questions you want to get into. This is just real in brief the stack we're using. Obviously JavaScript on the front end, since we're using HTML5 and Canvas. On the back end, we're using Node.js, and that is great, very easy to be able to use the same code you use on the front end to the back end, and kind of have the same simulation if you're running one on the front and the back end, and just use the code on both. HTML5 using the Canvas, everything that you saw there from you need a DOM for UI or anything. So as soon as you go full screen, it's as if you're playing just a desktop game. And for database, we're using MongoDB. We're with a NoSQL solution and a non-relational database because that structure fits games perfectly. A lot of the time you're saving state data, you're just saving the state of the game, and the structure of that data can change at any time. It's also very great for rapid development because, for the same reason, your data structure is changing constantly. And so you don't have a strict database form that you're adhering to, allows for the much easier, much more rapid development. And
so we're 100% JavaScript. That was really the idea, to streamline the stack. Because if you haven't used MongoDB, it's just JSON. And it all works really well together. So the engine we're using is, it's called the Isogenic engine. It's made by a company in the UK called Relian Software. And so we've been working closely with them since last summer. The engine is still, I guess technically it just hit 1.1 stable a few weeks ago. So we've been closely developing the game alongside the engine. And it's a pretty cool engine. You can check it out at, I believe it's isogenicengine.com. They've got a free version you can download. So it's not open source, although they're in talks with Mozilla right now, possibly open source it through them. But there is, again, the free version is available, which gives you all the features except for the multiplayer aspect. So it's really easy to get on there, download it, and start playing around with it. And then the license, I believe, is 2% revenues if you want the full thing. So really, the reason, there's a lot of HTML5 JavaScript game engines out there. I don't know how many of you have sort of played around with those. There's, Impact, a bunch of other ones, but really the reason we went with Isogenic Engine, and the thing that really sets this one apart is, again, it's in the canvas and it does isometric. It also does 2D, but isometric is really the magic it's got. Pretty much all the other engines out there right now just do 2D. Even a lot of the new WebGL game engines are just 2D. And we wanted to do an isometric viewpoint. Your same simulation run in the code. That same code will run right on the server, which makes doing those server-side operations a lot easier. And then it's also got full multiplayer support built in, so we do the multiplayer through WebSockets, and it's got options for Socket.io, but they've also built their own. It's called Net.io, which I believe is open source. And the advantage with Net.io, Socket.io is really nice, but it's sort of bulky. So Net.io really streamlines it and makes the data being passed between very slim, cuts out a lot of the headers and things like that. So again, rapid development. The engine is undergoing rapid development right now. It's pretty much full featured at this point. There's a few things that are missing that I'll talk about shortly. But again, if you're interested in game development, I strongly suggest checking out this engine. And let's see, the other engines, I think you've...
I played around a little bit around with Impact. Impact is much more of a lightweight. I mean, it's professional, but it's very lightweight. Isogenic is very feature heavy, very feature-laden, so you have a much more professional engine at your disposal. Also, with Impact, there's none of the back-end support. Isogenic engine, it integrates seamlessly with the client side and server side. So Impact, you're going to have to write your own server side or find something else.
Yeah, and there's actually, over the last few months, we've seen more and more engines popping up. So there are a few new ones that are in early development right now that have isometric view also. One I saw earlier this morning, actually, I think it was called the Sheet engine. It's got some pretty cool features. It's got real-time shadows built in, something I hope the Isogenic engine gets. But yeah, I mean, there's a lot going on in this space. Mainly, one of the big things we're still missing is tools to more easily develop with HTML5 games, but I definitely say it's advancing too. So yeah, one of the areas that's missing still, that's being worked on with Isogenic engine specifically, is audio. And I always hear this is an extreme pain point for games in the browser. So Isogenic engine suggests using a library called Sound Manager 2, which companies like SoundCloud use. There's a few problems with Sound Manager. The main one is that it uses Flash as a fallback. We don't use Flash. So the other one is it's only that only uses HTML5 audio element. And HTML5 audio element is really easy to use, and it's got some nice features, but it's pretty slow. It's not, you don't have precision control over it. You can't add filters and effects and different things of that nature. So that's where Web Audio API comes in, which is, in about the last year, Google has developed this, and it's now integrated into all the WebKit browsers, a lot of the mobile browsers now. It'll be coming to Firefox in the near future, and who knows when it'll come to Internet Explorer. But so we needed high quality audio for our game, and we went out and looked at a lot of different libraries that are out there. Most of them don't implement Web Audio API at all, and the ones that do that don't have any fallbacks. So we decided to write our own, and we open sourced it about 3 weeks ago. It's called Howler.js. And basically what Howler.js does is it defaults to Web Audio API. It gives us that fine-grained control over the audio playback, and builds in a lot of handy features like an automatic cache pool for the sound files. Of course, the play, pause, fade in, fade out, things of that nature. One of the cool things we built in is audio sprites, so you can define sort of segments of the audio file and then attach a name to those, sort of like you would with CSS sprites with an image sprite, and play back those pieces of the audio without having to load lots of different audio files. So let's see. This, I don't know if you can see this very well, but this is the code for Web Audio API, basic playback for Web Audio API. So HTML5 audio element, again, is great, and it's very simple. But we want the performance of Web Audio API. Unfortunately, with that advanced functionality, the API is a little bit more tricky. But essentially what it's doing here is it's doing an XHR request to download the audio data, and then with that data you can apply different effects, speed it up, slow it down, a lot of different advanced features. You decode that into a buffer, load it into the audio node, which then hooks into the speaker as the output. What we've done with Howler is we've abstracted all that away, added the HTML5 audio fallback and all those other features. And so if you want to play a sound, you just define it like that. It does everything behind the scenes, and then sound.play, and your sound is off and running. If you want to actually pull up some of the examples here, maybe. So, for example, the sprites that I was talking about, which is pretty handy for not just games, also just general interfaces. If you want to have button clicks, different things like that, you generally don't want to have a lot of different sounds. So basically, the sprite gets defined right here. You put a name on it, and the millisecond time, the start, and then the duration of that sound. And so you can just play the different sounds right away, like that. Which with HTML5 audio element, it works, but it's quite a bit slower. So the laser blasts would not overlap like that, and things of that nature.
Do you just use Awk for everything?
Use what?
Do you use Awk for your format?
No, so Howler will support pretty much any audio codec that the browsers support. Generally, to get full browser support, you need to use both MP3 and OGG, because I believe Firefox doesn't support MP3 right now. Everything else supports MP3. But so basically, the library will take the two sources that you provide, decide which one is best to use, and then only load that sound file. If you're using HTML5 audio element directly, it's going to load both audio files, regardless if the browser can play them. We'll talk about some of our.
I'll just
Alex. Got it. So there's obviously some challenges developing for HTML5 games. It's obviously very new. Like I said, there's not a lot of tools out there for it yet. And so we've had to sort of navigate some areas that might be sort of easier with other platforms. So scalability is obviously one, and just raw performance drawing on the canvas. You'd be surprised. I mean, there is hardware acceleration built into the canvas pretty much everywhere now. And on Casino RPG now, we're getting pretty steady, 60 frames per second.
If you have a really good GPU, you can get up to like 200 frames per second.
Yeah, our artist gets like 200 on his artist really beastly computer. But on regular computers, yeah, I mean, it gets regular, very smooth animations. You want to talk about some of the things you work on?
One of the things, performance-wise, one of the big problems we have is Firefox, Mac, and Linux. For some reason, they don't support. What was it?
They won't do hardware acceleration. They just do software.
So you'll see a steady 60 in Chrome, and then it'll grind down to like 20 in Firefox. And I'm not sure why they made that kind of decision, but it's been a little bit of a development hassle in the meantime. The image sizes in the GPU, the way the GPU handles images is a little tricky. So if you have too much image data, if you just a few pixels over in the wrong direction, then your GPU will be you'll be using maybe 10% of your GPU, and in your case, it'll suddenly wave between 80% and 20%.
So the big issue comes with animations. So for example, when we have like people walking on the street, that's done with sprite sheets. So the full pre-rendered, walking animation of the player. And the problem is the GPU is having to swap out that image on each frame. So as the image size gets bigger, even if it's the completely empty image, if there's it's just a transparent PNG, it still has to go through all that data, and you sort of just hit a point where it just drops off, and you get no more performance. So we've had to work around that sort of painfully by chopping up images. And for example, the character images, one character is, I think, 82 separate images, which would be nice to have it in one sprite. We've had to slice that into 9 separate images for each character, make the GPU happy. Another area was with the buildings. So the buildings are pretty large images. We need the sprite sheet from each angle. And so we've had to do some tricky things with the light animations on the buildings, cutting out the empty space around those to get the performance to work.
How many players per server are you guys expecting to be able to support?
Yeah, so we're still working on that, but we're expecting concurrent. It depends. So we're doing hosting in the cloud. So it depends, what size the instance is, but we think the smallest instance, one CPU unit and a gig of RAM should support about 1,000 concurrent players. So it's fairly scalable, and you can scale up one instance pretty high.
While we're on the subject, is your client-server relationship more one like that the client just simply displays what's going on in the server, like a remote desktop kind of thing, or is your architecture
Talking about like an authoritative server?
Yeah, are you running parallel simulations in the client and server, or are you just displaying the server?
Somewhat. So
one of the things like we were talking about, with the more scalability you have, if you're talking about, there are kind of 2 ways to do it. One is to render in real time, where the server is constantly streaming data to the client on all the positions of everything that's on stream. And the second way is to do where a lot of different traditional RPGs and stuff do it, is every time a player moves, you just send a move request to the client, and the client simulates that move. And so since you don't have to constantly stream that entity data to the client side, you're actually removing a lot of the bandwidth. So what we're doing is, to support scalability, is we're only streaming moves instead of streaming them constantly. And that allowed us to scale up a lot more with a bit less.
Right. But the server does keep a state of where everything is at all times. So you couldn't, type into the console and move all the way to the other side of the map.
Is there like some sort of authoritative push, like once a second or something, to keep the client synced, or do you not?
So, yeah, that's a good question. That is something that's built into the engine that we could use. But for this game, it's not really that necessary, just because basically it's people walking around outside, and they're going to know if someone else is off by a couple pixels or something. So we're just opting not to put that load on our issue.
Yeah, and I think one more answer to the question you're asking, we're trying to keep as much state data as possible in the database rather than being just processed in the server. That way we can spin up as many instances as we need. As long as we're keeping that state data in the database, we can do replicated requests all the time.
Do you load all the assets to the browser?
No, so we've got a dynamic loader built in. So for example, with the characters, there's no way we could do it, obviously. Right now, we've got about 100 character customizations, which renders out to about 101,000 images. So those get dynamically loaded in. Some things get preloaded in that are, the UI, the tile set for the ground, things like that. But other areas that don't need to get loaded in right away will get loaded in the back.
You mentioned that you're state data, so you spin up your server. So will each server instance be an identical copy of the world, or will each server instance have its own?
Now they all hook into the same
So
game.
they all.
Yeah, we would like to keep a persistent, rather than sharding servers.
So how are you going to deal with kind of growth of the world as you get thousands of users and build in your own?
Yeah, there's two ways. One, we're going to, after launch, slowly start to roll out multiple cities, which are all part of the same game world, but you'll have to travel to those separate cities. And two, the game world, so it's again city-based. It'll grow out automatically based on population, and then to keep things spread out. There's two things. If, for example, if a player doesn't log in for a month or two, their casino will get sold back to the bank, and then another new player can come in and take their spot. And also, when players come into the game, they're not going to just go to the center of the map where everyone's been from the beginning. They'll be more sort of intelligently placed around the game world to match them with casinos. We sort of want them to go into.
Come back in about 12 months, and I'm sure we'll be giving a presentation on the challenges.
Yeah.
So that'll help.
So another thing with performance is caching, which has been a big boost, and general browser caching as well, but specifically caching draws on an off-DOM canvas. So drawing to an off-DOM canvas is dramatically faster than drawing to the main canvas. So a lot of the highly graphical and CPU-intensive things that we draw off-screen, off-DOM, render it there, cache it there, and then draw it each stick onto the main canvas.
So it's kind of like you're swapping buffers.
Yeah. Let's see. Mobile. So mobile. So right out the gate, we aren't officially going to be supporting smartphones. It's mainly going to be tablet and desktop. It will run on smartphones just fine, but you run into some issues with screen size. And actually, interestingly enough, an iPhone actually gets a better frame rate than an iPad, just because it's rendering less data on the screen. And it's, but you run into UI issues and things like that. But generally the performance on mobile is a lot better than you would expect, with one exception. So we tried to do the high DPI displays. That's not ready to work with HTML5 yet. Basically, we got about 2 frames per second once we switched to that. But other than that, it still looks pretty good. So, do you have anything else on that? Okay. We'd be happy to answer any other questions. There we go. Questions.
How do you organize your code base?
So we actually use John Ressick made like a sort of a class structure that the engine actually uses, and so we're following that. You want to talk a little bit about that?
Yeah, I was about to say since we've done a lot of talking about that recently, and I could cover an entire presentation on itself on how you organize the game and how you start everything. Basically, the client server exists in separate classes, and that's where they divide. There's not really, I can't really describe it unless showing it.
Well, mainly to narrow it down more, like in terms of, so the game engine that we're working on is, I'm not as familiar with JavaScript, but it uses a scripting language that's similar to JavaScript. And you have to do like a do file, like run each file as a script. And what I found was that as the code base got bigger, keeping track of what file needs to launch what other thing, bringing what resource became more difficult. So
are you using JavaScript kind of like inheritance-based or prototype?
Oh, well, we're using a different language. It's prototype-based.
Okay, it's prototype-based. So you do use it, like, are you declaring prototypes and assigning, or are you using kind of like John Ressick's style?
What I ended up doing for ours was I had every file is wrapped in a method, which is kind of like wrapping in a function in JavaScript, like recommends.
Yeah.
So I ended up doing that, and so now all of our script things is a method. So when you execute the script, it doesn't actually run anything; it just creates a method. Because the method takes arguments, which are the protos, the things in that script need. And so that was how instead of having to say do file, and pick stuff up afterwards, I set it up to where when it initially loads, it just runs all the scripts, but all the scripts are just creating methods, and the dependencies of each proto, like this one proto might drive another, get passed in as arguments.
Yeah, I think you basically described the exact how you have it set up.
Right.
Inheritance structure, yes. Yeah. I thought you were asking more about like how do you organize like that main project. Yeah, there's a kind of a main that main stuff. We have to add classes.
Well, and so when we deploy it, we're not deploying all the different files. We've got a couple hundred different files. The deploy script will take all the files, combine them into one, minify it, and so there's just one game.js to get served to the client.
Pretty good.
It's
getting bigger.
It's about 600K right now, so not too bad. Yeah. So the rest of the assets, though, we obviously don't load all these in, but with all the character images and everything, it's about 2 gigs. But generally, when we load the game in, you'll only be loading 4 or 5 megs of data. So yeah, this is the current build of the game. Do what? Yeah, so we've got sort of the basic version of the NPCs right now. You see a bug right there, but so right now the NPCs are just sort of stupid and they just walk around from platoon, But yeah, by the time, well, at some point they will be going into the casinos, and that's sort of what Luke's working on right now.
Yeah, there's a tycoon simulation running behind it all. When you own a casino, it depends on a whole lot of factors about running the casino. And what we're going to do is there's going to be a simulation that's going to be running on the server. We're going to be pushing different things to the from the simulation to the client, and the AIs are just going to kind of act it out. So it's all running in the server, and all these AIs, right now, all the AIs are running in the client, but the future goal is to have them all running on the server. So every player will be saying the same thing. And so, like, if AIs might get in a fight or win a jackpot. So,
Like your mini map there.
Like running map, yeah, that's actually that's a good example of the canvas caching that he was talking about.
Yeah.
When you load up the game, it takes all the texture data, draws the map on another canvas, and then it just cuts out where you're at. Right there.
So if you play 24 hours, how's the memory browser instead of this goes, or is it just like Firefox is 2 gigs?
Depends on how well the JavaScript garbage plug works. All the entities, when you move, like when you go into a casino, the entire world map, all the AIs and everything are cleaned up. And all the references to them are right. Where the garbage collector runs, it should clear up all those lost.
Yeah, I'm sure we've got some issues with that at the moment, but we'll be heavily optimizing on that as we get closer to beta.
The modern JavaScript garbage collectors not cause or either from
No, they used to be really bad at that, but we haven't had any issues at this point. Don't see any pauses or lags from that.
And we don't have anybody playing 4 or 5 hours yet, so you might see that. But I mean, the great thing about JavaScript game is to reset. All you got to do is Control-R, refresh the browser, and you're back.
Yeah, so the Kickstarter was a good learning experience. It was a ton of work. So I think we had 6 hours to go when we reached the goal. Yeah, I think the main takeaway is you need to you need to build some media connections before you launch the Kickstarter instead of after. So you're not spending like a month emailing people and tweeting people. But yeah, I mean, it was definitely a good experience. I'm glad we did the Kickstarter, and it's definitely it helped us just hire an art director. So that's exciting.
If you promote on Reddit, you better be ready to just brush things off. Yeah, Reddit is evil when it comes to any kind of self-promotion.
On Reddit.
Yeah, did you ever see
Isn't this Farmville? No,
Yeah.
it's not Farmville.
Yeah, we posted on Reddit and we got some pretty harsh comments.
Yeah,
Definitely the full band.
Yeah, so.
So how do you make money from the game?
Yeah, so the game's free. So that's one thing that we've already launched as a game platform, and it's got, you can actually see it here, it's got this universal virtual currency built in called Gold, so players can just, so it's all microtransaction based, slash there's a optional subscription element built in as well. So they can go and buy the Gold, spend it on things like, you know, they want a pirate costume for their character. You know. Okay. All right, last question.
we are trying to avoid that.
No pressure, it needs to be a good one. Oh, and we have stickers, by the way, if anyone.
I'd like to actually also point out a couple of our interns in the back. Jason and Susan, the two sitting in the chair right back there. There's a couple of interns from Simpson.
I also want to announce if any of you are interested in game development, we are starting up a game developer meetup. First meeting will be next month at some point, so you can check that out and get on the list at OKC.js.